And we're talking about signal notation as well. So what do you remember about the term sequence? What does it mean, or what does it refer to? Yeah. So sequence, we're talking about just an ordered list, meaning that we're not just have a list of numbers, we have a certain order to it. So I'm going to say ordered list of, I'm going to say numeric terms. So we've got a bunch of terms that have some numeric connection, there's some order to it. It's not just a random list.
Did you define that numeric term?
Any term that's a number. So each term in the sequence is a number. So for example, this is a common one. 1, 2. There's a sequence. What are the terms of the sequence? What? Yes. You can give it. Each term, this term is 5, 6 term is 6, and this one. Very simple. Now, we've got two types of formulas we use to describe these: explicit and the recursive. With an explicit formula, it always tells you, if you plug in n, it will tell you what the term is. So an example, an equals, this is a 5n minus 2. If I plug in 1, what do I get? 3. And so the first term in the sequence is 3. If I plug in 2, so I have 3, 8. If I plug in 10, what would I get? 48. And we can plug in any number we want, and this instantly tells us what the term is. Make sense?
What is the formula?
It's going to be a formula that gives the term number, or the term, by inputting the term number. Now, when we talk about a recursive formula, when we talk about recursive formulas, each term is dependent on previous terms, except first few or first one. So example that would be, say, a1 equals 4, an is equal to 2an minus 1 plus 3n for n greater than or equal to 2. Yes?
Does it say after term by order?
Gets determined by inputting the number, a term number. Okay, so when we talk about a recursive formula, what is the first term of the sequence? 4. So a1 equals 4. What is a2 equal to? Okay, well, to get it, we're going to plug it into here, because it's for n greater than or equal to 2, we're using this formula. So if we plug in 2 here, we get 2 times a 2 minus 1 plus 3 times 2. What is 2 minus 1? So this is the same as saying 2 times a1 plus 6. Right?
What is the formula?
Right here is the one we're using to get these. What is a1? So this is going to be 2 times 4, which is plus 6. So a2 is 14. How about a3? What are we going to do?
Why don't you call it A of 3?
A of 3? Because when you deal with sequence of terms, we usually do AN would be your term N, nth term of the sequence. And it's not necessarily a function in all cases. Yes.
There's definitely that.
Except first, so possibly the first term or terms. So how do you get A3? 2 times A. So what's A3 minus 1? So 2 times A2 plus 3 times 3. So 2 times 14 is 28 plus 9, which is 37. Okay, what if I wanted A10? What do I have to do to get that? I have to get A9. And to get A9, I have to get A8, to get A7. Okay, this is why we call it the recursive, because each term is dependent on the previous term. So you can't just instantly jump to the answer. Like with the explicit formula, when you plugged in N, you instantly got what is the nth term, right? Here, we plug in 10. To get the 10th term, we're going to have to go back, get the 9th term, get the 8th term, 7th, 6th, all the way back. No, these are just some examples. Yeah. So I'm going to show you a very famous recursive.
Is the A1, is it dependent on anything?
It's just what it started at. It's just a certain example.
For, like, problems on homework, would it give us an A3 or something?
Sometimes. Yes, so you don't have to work backwards. We'll get to probably something like that. So this is a famous recursive. A1 equals 1, A2 equals 1, AN equals AN minus 1 plus AN minus 2 for n greater than or equal to 3. So what's the first term? What's the second term? What's the third term? What's the next one? Yes, this is the Fibonacci sequence. So this is a recursive definition of the Fibonacci sequence. We start with 1, 1, and then each term after that is dependent on taking the previous 2 and adding together. So if we wanted the third term, we take A2 plus A1. Now you also hear terms converge and diverge. Or convergent and divergent. What do you think these mean when we talk about series or sequences, I should say?
Join together.
Yeah, how about this? We say A1 equals, let's just say 10. AN equals square root of AN minus 1. Okay, so get your calculators out. What is the first term of the sequence? Okay. But I'll show you how you can do some of these quickly with the calculator. So, first term is 10. So 10, enter. You get the second term, what do we have to do to the first term? Square root it. So what I'm going to do is take square root of my previous answer, which is there. The second term is going to be there. Then I switch to enter again, third term, fourth term, fifth term, and so on. What's happening as I keep going? Yeah. So you can go as far as the calculator can handle. Eventually, it's going to say this is 1. So does this converge or diverge?
And then ever pass one. Can you ever pass one?
No. So even if you have high-end calculators, this will never get, even if you have one that can hold 1,000,000 digits, this will never go below 1. So this is an example of something that converges.
Wait.
Why do we have to do square root of 10?
Because,
This is square of 10 and 10.
but the thing is, you want to be able to push enter instead of, because if I put 10, and if I put square root of 10,
Oh, I get it. Because the answer says the answer before.
yeah, the previous answer, which is what a recursive definition is based on.
Mine's not doing it. Now it's doing it. I stopped looking at it.
So what's A2?
Okay, what is A2?
One?
3.162277766, whatever.
It is just going back
Oh.
to tell me. When it is now, oh my gosh. Okay. Oh.
Is this sequence or series?
Okay, this is a sequence. Because this keeps going closer and closer to a sequence if we kept putting these numbers. So what would be an example of something that's diverging? How about this? A1 equals 5. AN equals, let's just say n to the 5. Okay, if I plug in 1, what do I get? Alright, sorry, not, it should be AN minus 1. To make it the same form, to the 5th. So what would the second term of this be?
Wait, so if you plug in 1 and 0.
3,125. What would the third term be? 3,125 raised to the 5th. And then that one raised to the 5th. So, does this converge to a certain number or diverge? Yeah.
How would you solve it to like 2?
Second term, you plug in, notice, if I plug 2 in, 2 minus 1 in,
1.
so A1 is what I have here, right, for second term?
Oh, right.
So that's A1, or A2 equals A1 to the 5th.
What if there's 0?
It's what 0?
I don't know what 5 is this is.
If this is 0, well, square root of 0 is 0, we'll just always say 0.
Okay.
What?
Why do you know what 5 is?
Because it was on your test. 3,125 was like the last problem test. Okay, and then A3 would be this. So A3 would be A1 to the 5th to the 5th.
So you have to do the answer.
And then A4, yeah. A4, you get bigger and bigger. So what will you define convergence to be? Okay, as n goes to infinity, what happens?
Y goes, approaches 1.
It approaches some value.
What? A approaches 1? Or Y?
As n goes to infinity, approaches
N?
some constant speed.
Or it doesn't matter?
No. So for example, if we did, let's see, A1 equals, or let's do AN equals 1 over n. Tell me as you plug in bigger and bigger numbers for n, what does this go to? 0. So this converges at 0.
So it doesn't have to be always square root.
No. It's any term that converges or goes to a certain value in the long run.
And divergence is just any time
Well, it doesn't necessarily have to get bigger, it could get smaller too. But it doesn't go to a certain value in the end.
Like what?
This is an example.
No, like small.
So what if I did negative of, and so this is, the answer is the negative an minus 1 to the 5th.
Okay, other than that, like, is there anything else?
How about an equals negative 4n plus 3?
Wait, what did you say about divergence?
It doesn't approach a certain set value,
There's bigger?
bigger or smaller.
Oh.
But I mean, there are some that it doesn't necessarily even just get bigger or smaller. It just doesn't stay at a certain value. How about this one? an equals negative 1 to the n.
Wait, so divergence can get bigger and smaller?
Or not, or neither.
That's one.
So if I plug in 1, what does this equal to?
One.
If I plug in 2, 3, 4. Okay? So is this going to a certain value? And staying there?
Value?
No, to one value. Okay?
Did you plug in negative numbers, Fred?
Can I do what?
Fraction.
To do what?
Negative numbers, Fred.
Typically, we're looking at the first term, second term, third term of the sequence. So generally, no. Now, sometimes you might start at the 0th term of the sequence. So you might plug in 0, 1, 2, 3. But generally, in this format, we don't deal with the negative terms of a sequence. Now, series.
How much more notes are there?
A bunch.
Actually?
So a series is the sum of a sequence. And if you want the nth partial sum is the sum of first in term. So oftentimes we don't sum up the whole sequence. Why not? Yeah, a lot of them go to infinity or negative infinity, so we often don't sum up the whole sequence. So we only do maybe in terms of the sequence, or the partial sum of the sequence.
What do you think?
We might sum up only the first 5 terms, which would be the 5th partial sum.
Oh.
And we've got special notation for this that you need to know. Sigma notation.
Or just series or for like all
Well, look at this.
Sigma?
Sigma.
Sigma?
The Greek letter sigma. We're going to draw that.
Oh, that's it.
Can I go to the next page if they will go?
Yeah, this is just directly your page, just continuing at the top. Let's just say B to C of A. So this is sigma notation.
Oh.
What this means is we're going to take, I'm going to put AN. This means we're going to start at A to B plus A to B plus 1 plus A to B plus 2, all the way until we get A to C. So what do you mean by that? Say if I did this, sum n equals 1 to 6 of, say, 2n. What is the first term of this sequence? 2. 2. So this means 2 plus, then you change this to 1, or 2 I mean. 1. Because what this means is we're going to start at 1 and go until we get 6. Okay. So we plug in 2 for the second term. So 4 plus 6 plus 8 plus plus. And we stop at 12 because that's where n equals 6. So this is where we're starting. This is where we're ending. And because it's sigma, it's saying we're adding it together. So I'm going to highlight this. Okay. A to the B, or what do you mean?
Oh, 2A.
This is 2n right here.
It's 2A.
Where are you looking?
It's 2 equal A.
AN is my equation that's telling me the terms of the sequence.
So 2 is A.
So AN, so in this case, AN equals 2N.
So 2 is A.
Is that in the
No.
bottom, or is it A-N?
N is a subscript right here. It's not A, this is not A times N, it's A sub N.
And then what is that then?
So A is
So
2.
it's saying for any given term N.
So
So
A is
that
2.
is 2 multiplied by N?
Yes, right here, this is 2N. This is not 2 sub N.
Then where's the substitute? Where's the?
Okay, I'm not sure you're following this. Okay, this is a general term. So remember, back here, A1 or AN given a certain form. So AN is my formula. So if I want the fifth term, N is 5. So I say A5 is the fifth term of this sequence.
And so it'd be 5 times 2.
Yeah, in this case, yes.
I have a
So
question.
patient. So AN is like my function, like y equals something comparable to that, or f of x equals. Where this is just saying this is our term number, where n is our term number. So when we're looking at this here, this is the general form saying for some sequence AN, we're going to add up all the terms of it from B till we get to C. So this is just saying we're going to add up all the terms of the sequence. Here I gave you a specific sequence, 2n. So AN equals 2n. So here we're starting at 1, plug in 1 for n. Then we go to the next one, 2, 3, 4, 5, 6, until we plug in everything from 1 to 6.
Oh, so A subscript N is like the title for 2 times 1. I think it's all right.
Okay, and then here's what we have. So now if we did it at 10, 20, 30, so the answer in this case is 42. So if we do another one, n equals, say, 0 to 4 of, let's say, n to the, let's actually go 3 to the n.
Wait, is 3 to the N part of the sigma?
This is like an operator.
Okay, so that's the operator you're giving me 3 to the N.
This
It's
operator.
not part of the operator, okay.
Right.
It looks like it's part of the operator.
So if we plug in 0, what are we going to get?
1.
1. So you have 1 plus, plug in 1, plug in 2, plug in 3,
16.
plug in 4.
Oh, 81.
So I see you've got 90, so 30 is 120, so I get 121. So what basically the sigma is a function that starts operator says we're adding up in a sequence as far as we want. So I want the first 20 terms of a sequence, I'd say n equals 1 to 20.
Where do you put N? Like, is there a specific place?
You could set it equals 121. It's just I'm just putting it down here because I didn't want to put it too tightly there.
How much? What's your difference?
That's about it.
Oh, that's
Now, there's one more thing I want to show you that you don't have to write down. Pi notation.
the pi notation.
So,
Why do we have to write this down?
it's not in your book, or I don't think it talks about it in your book.
Why is it?
To note that sigma notation is not the only of this format. No, we use a capital pi when you're dealing with pi notation, just like we use a capital sigma here.
Is it capital pi?
Yes.
What is the lowercase?
Okay? Lowercase pi is the number 3.141592665. Capital pi. This is, we're plugging in, we do the same sort of thing. Plug in 1, we get 3. Plug in 2, we're going to get 6. But this time, instead of adding, you are multiplying. So plug in 3, we're going to get 9. Plug in 4, we're going to get 12.
So what is it?
I don't believe it's on the homework.
What is it? Central, what is it? Go.
What is it? The
What's 18 times 108?
18 times 108, say 10 times 108 is 1,080. 8 times 108,
864.
yeah. How'd it go?
I don't know that.
Okay, but your book might mention this in one of the problems, but I don't think you actually have to do any problems that are based on that. We don't, and even case like calculus and stuff, you may not even ever see that. I think I only saw it in a couple of the classes I took.
So is it complicated? Or
No, they're just not used very much.
Are we done? We're done?
Yeah. So I'm going to do another example here. Let's see. N equals 1 to 20 of 4n plus 5. Would you want to do this by hand?
What?
Would you want to do this one by hand?
No.
Yeah, your calculator can do it for you. Now, depending on the calculator you have, it uses different
Can they
notation.
do divergence?
So this calculator, if you have a TI-84, it actually does the summation thing for you, much easier. So this one you want to do the sum, so go math, and it's under, I believe, at the towards bottom here. No, numeric. The sum, which is where is it?
Summation?
Yeah.
That's 0. 9.
So this one?
Yeah, it's under math.
Oh.
Over.
Where is this sum one?
We're looking for